Hi everybody! So in today's video we're going to be going over some new derivative rules that you're going to need to know. So far we've learned about power rule and how to take the derivative of polynomials. Now we're going to learn how to take derivatives of other types of functions. And we're going to start today with trigonometric functions. Now the first thing I want you to notice when we go through these rules is that we're trying to find the derivative with respect to x. That's why it says dx on the bottom. But inside of the sine function, we have the variable u. The reason we have a u there is that u represents a function of x. Sometimes, instead of just x inside of a trigonometric function, we're going to have something like 3x or 2x. Because there can be things that are not just an x, we're going to need to use the variable u to represent a function of x, something we're doing to x. And that's going to remind us that the chain rule, which we've already learned, still applies even with these new rules. So for example, if I was to say, how would you find the derivative of sine? You would say the derivative is cosine of whatever was already inside there, leave the inside alone, but then multiply by the derivative of whatever was inside there. And the reason you would do that is that this part right here is the chain. So chain rule says you multiply by the derivative of whatever is inside, and to represent that so that we remember to always do that, we usually write it like this. The derivative of sine is cosine, you leave the inside alone, whatever was there, and then multiply by the derivative of the inside. Let's go through a few more rules here. So the derivative of cosine would be negative sine, and you would leave the inside alone, don't change it, so we would leave it as a u, and then multiply by the derivative of whatever was inside there, so the chain. To take the derivative of tangent is secant squared, and whatever's inside there we leave alone. Just leave it as whatever it was stays the same. And then we multiply by the derivative of whatever is inside there. That's the chain. Now once you kind of know that sine is cosine, cosine is negative sine, and tangent is secant squared, it's kind of easier to remember these functions rules. The derivative of cosecant is negative cosecant of whatever was inside there. Cotangent of whatever was inside there times the derivative of whatever was inside there. The derivative of secant would be secant of whatever was inside there times tangent of whatever was inside there times the derivative of what's inside, so the chain. And the derivative of cotangent would be negative cosecant squared of whatever was inside there, leave it alone, times the derivative of whatever was inside there, so the chain. Now there are a couple patterns here that can help you remember these rules. For example, one of the patterns that students usually like is that if your original function starts with c, it means change the sign. So cosine becomes a negative when you take the derivative. Cosecant becomes a negative when you take the derivative, and cotangent becomes a negative when you take the derivative. So c means change the sign. Now anything that starts with an s originally, like sine or secant, stays the same. So if sine is positive, the derivative is positive. If secant is positive, the derivative is positive. One of the other patterns that's really easy to see is that both tangent and cotangent are a function squared. These are the only ones that have a squared in their derivative. Tangent is secant squared, and cotangent is negative cosecant squared. Now, I like to think about those functions as partners. Tangent is partnered up with secant. Cotangent is partnered up with cosecant. So, those same partners apply when you do the derivative of cosecant and secant. Cosecant and secant are also very similar. Both of these derivatives are the original function, so cosecant has cosecant as part of the derivative, times the partner function, cotangent. Cotangent and cosecant are partners. Cosecant is itself and its partner. Secant is itself and its partner. Cotangent is its partner squared. Tangent is its partner squared. So these are all little patterns that students in the past have pointed out to me that helps them memorize these derivative rules, but at the end of the day, you really just need to know these derivative rules. Just like the power rule says, drop the power and subtract 1, these are rules that help us take the derivative of other types of functions that don't have powers necessarily. So let's do a couple example problems where we can see how to take these derivatives. So if f of x is cosine of 3x, then find f prime of pi over 9. Let's start by taking the derivative without plugging in any numbers. So first we're going to take the derivative of f. To take the derivative of cosine, cosine says it should be negative sine, leave the inside alone. So I would have negative sine of, and I'm going to copy down the 3x. I'm going to leave the inside alone, times the derivative of the inside. The derivative of 3x is 3. Now if I wanted to find f prime of pi over 9, what I would do is take the pi over 9 and plug it into this equation that I've just created instead of x. Now 3 times pi over 9 would just be pi over 3. If I think about my unit circle, the sine value at pi over 3 is the square root of 3 over 2. So if I simplify this, I would have negative 3 square roots of 3 all over 2, which is option E. Now for problem number 2, I'm going to need to use product rule because in this problem I have a first function, x squared, times another function, sine. Now product rule says, and this is a rule we already learned, that you copy the first one, x squared, take the derivative of the second one. The derivative of sine would be cosine, leave the inside alone, times the derivative of the inside, which would be 2. Then I'm going to put a plus sign. I'm going to copy the second function, which is sine of 2x, and take the derivative of the first function, which would just be 2x. Now I could simplify that a little bit, so what I would do then is I would probably take this 2 and move it to the beginning, so I would have 2 and then the x squared cosine of 2x plus, and I would probably take this 2x and move it to the beginning of that term, so I would have 2x times sine of 2x. Now if I look at my answer choices, none of them look like that, but several of them have a common factor taken out. So just like we talked about in the past, taking out a common factor can help us make our answer match the answer on a multiple choice question. Both of these terms have a common factor of 2x. So I would take out the 2x and I would write down what's left. What's left in the first term is x times the cosine of 2x. And the second term is just sine of 2x. Now, once I've done that, I can see that that matches option E. The only difference is that in option E, the x cosine of 2x and the sine of 2x are flip-flopped inside the parentheses, which is totally okay because it's an addition problem. All right, now let's learn about a different set of rules. So those are the trig rules. Now we're going to do exponential and logarithmic rules. So same as before, the u represents a function of x. The derivative of 2 to the u, so any number that's not e to the u power would be, we copy the original, 2 to the u, times the ln of whatever the base is. So in this case, times 2. Then times the derivative of the inside. So the basic rule is for anything to a power where the power is the variable, you copy the original and take the natural log of the base. That's your rule. It could be a 3, and then you would copy 3 to the u times ln of 3, and then the derivative of the power, the chain. Now, this becomes a little bit more of a specialized rule when we're using e. So when we're using e and we apply the same rule, because e is just a number, it's just like the number 3 basically, we would have e to the u times the natural log of e times du over dx. But we know a special rule about the natural log of e. The natural log of e is worth 1. So we usually say that the simplified derivative rule here is e to the u times du over dx, because ln of e is always going to give you 1, so it's going to simplify every time. So it's the same rule that we did here, it's just a specialized case because the ln of e simplifies. So we usually say that the derivative of e to the something is e to the something times the derivative of the something, the power. Now with a logarithm, it's very similar. The derivative of a logarithm is 1 over whatever was inside. So just like there was a u here, it'd be 1 over whatever was inside times the natural log of the base, which in this case was 2. Then we need to do the chain, so times du over dx. Now there's a specialized example here for when we have a natural log, because the invisible base here is an e. So when we do this rule with natural log, we're going to have 1 over u times the natural log of e times du over dx. But the natural log of e is worth 1. It simplifies just like last time. So the shorter rule would be 1 over u times du over dx. So we usually say that the derivative of natural log is just 1 over the stuff times the chain. Let's look at a couple examples. So this one says if f of x is e to the 2 over x, then find f prime. So when we want to take the derivative of e to the something, the rule says the derivative of e to the something is just e to the something. So I would copy the original down. But then I need to multiply by the derivative of the power. Now 2 over x is really 2x to the negative 1. And I usually find it easier to write the derivative if I rewrite that with a negative power. So the derivative there would be negative 2x to the negative 2. I'm using the power rule, so I'm dropping the negative 1 and subtracting 1. Now if I simplify that, I'm going to move this x squared to the bottom, and so I'm going to have the first part here is going to go at the beginning. So I'm going to have negative 2 over x squared, and then times e to the 2 over x. And that matches, it looks like option D. For problem number 2, if f of x is the natural log of x squared, then I'm going to need to use chain rule here. So to find the derivative, we start with the outside. The outside is the squared. So I would drop the 2, leave the inside alone, subtract 1 from the power. So I'm leaving the natural log alone. Then times the derivative of the inside. Now the derivative of natural log is just 1 over whatever was inside of there, so 1 over x, times the derivative of the inside. Now the derivative of x is just 1. If I simplify this a little bit, I'm going to have 2 times 1 is just 2 times the natural log of x all over x. Now I want to find this at a specific value. It's the square root of e. So I'm going to have 2 times the natural log of the square root of e all over the square root of e. Now clearly that doesn't match any of my answers, but this does actually simplify. Square root of e is really e to the 1/2. We know that the natural log of e is 1, so we would have just the 1/2 left as part of our answer. So we would have 2 times just the 1/2 all over the square root of e. Now 2 times 1/2 cancels, so we just get 1 over the square root of e, which is option D. All right, there's one more set of rules that we need to talk about. So the last set of rules are the rules for inverse trigonometric functions. Now again, these are just rules you're going to need to know and to memorize. So the rule for the derivative of inverse sine would be 1 over the square root of 1 minus whatever's inside there squared times the chain, the derivative of whatever was inside there. The derivative of inverse cosine would be the derivative of inverse cosine, I'm trying to think of why I arranged them this way, and I don't think I arranged them this way in any particular reason. So the derivative of inverse cosine would just be -1 over the square root of 1 minus u squared du over dx. So times the chain. These two are related because sine and cosine have the same rule. It's just this one's a positive and this one's a negative. Now inverse tangent would be 1 over 1 plus whatever's inside there, so u squared, times the derivative of whatever's inside there. And inverse cotangent would just be -1 over 1 plus whatever's inside there squared, times the derivative of whatever is inside there. So these two are kind of partners. They're the same exact derivative, it's just inverse tangent is positive, inverse cotangent is negative. Inverse secant is 1 over the absolute value of whatever is inside there times the square root of whatever is inside there minus squared minus 1 times du over dx, the chain. And inverse cosecant is just the same thing but negative. So -1 over the absolute value of whatever's inside there, square root of u squared minus 1 times du over dx. So these are just rules you're going to have to know. They are related to each other. So sine and cosine, same thing, it's just this one's negative. Tangent and cotangent, same thing, it's just this one's negative. Cosecant and secant, same thing, except for cosecant is negative. You'll notice that the same thing we talked about with trig, where all of the c's stand for change. The c's are the ones that become negative, cosine, cosecant, and cotangent. All right, how would you actually do this? So if I wanted to find the derivative of inverse sine of x cubed, I would start by using the rule. So the rule says do 1 over the square root of 1 minus whatever was inside here squared. So I would have x cubed squared. Then I would multiply by the derivative of whatever was inside there, so 3x squared. Now I'm going to simplify that just a little bit. So the 3x squared will just go on the top, and x cubed squared would just be 1 minus x to the 6th. If I wanted to find the derivative of inverse secant, the derivative of inverse secant, the rule is you do 1 over the absolute value of whatever's inside here times the square root of whatever's inside there squared minus 1 times the derivative of what's inside there, which would just be 2. Now we can actually simplify this a little bit. So absolute value means take whatever's inside there and make it positive. X could be anything. So we don't know if X is positive or negative, but the number 2 is positive. So we can actually take that out of the absolute value. So I'm going to go ahead and throw this 2 on the top. I'm going to move this 2 out of the absolute value and leave the X on the inside because we don't know if it's positive or negative. 2x squared would be 4x squared minus 1. And the reason we would be interested in doing that is that now the 2's will cancel. And so we will end up with 1 over the absolute value of x times the square root of 4x squared minus 1. All right, I know it's a bit of a longer video. There were a lot of rules for us to talk about. I really appreciate you guys sticking with it and watching it, and we will be practicing this in class for a couple days now. So I will see you for that. Thanks. Bye.